Welcome back to Switch to Linux. Well, today we're going to do a little bit of a longer tutorial here, and this is kind of put together a little bit differently than I've put these together before. So let me know how you like this in the comments down there, and maybe I'll do more videos like this. So what we're actually doing is I want to build upon my past success using OpenMediaVault, and we're going to actually build a very low power Raspberry Pi NAS. The objective here is to get my power usage down and have a system that is up and running and just as functional. And I'm actually recording this video in stages, so by the end of the video, I'll let you know how it works. But here at the beginning, I'm not 100% sure. Based on my initial tests, actually the server for Raspberry Pi actually runs just as good as the micro tower that I'm actually currently running on, which you will see. Now, of course, in a previous video, I actually showed you how I built that. I using a Dell Inspiron micro tower, I modified it by pulling out the CD drive. I took out the single 3.5-inch hard drive. I put an adapter in there and put two internal 1 terabyte laptop hard drives in there. I created a RAID system, and I've actually been using that as my central office NAS and media server for about 3 years now. And frankly, it's in good shape and it can keep going. The reason we're doing this here is I want to decrease my power. This is a computer that is always on, so I want to cut back the power. I want to make it much smaller so it's easier to be much more portable. I don't have a big computer tower sitting around here. And ultimately have something that is just a little bit newer as far as things go. So of course we're using OpenMediaVault, and looking at the OpenMediaVault website here, we can actually come on to the website. It's openmediavault.org. This is what I'm using. It is based on Debian. And on my personal one, I also have an ebook server on, which I have separate videos about that, and that will be something that I need to get installed on this one as well. But hey, that's future video stuff. We're not going to worry about putting a book server on here, just OpenMediaVault. So you can head on over to the download page, and they don't actually have images for the Raspberry Pi anymore, but they do have some install scripts to make that work. I did want to run mine utilizing Debian instead of the Raspberry Pi OS because of that kind of Microsoft snafu. But OpenMediaVault does require some packages that there's 2 older versions on Debian Buster and 2 newer versions on Debian SID. And so as much as I wanted to, I did drop back down to the Raspberry Pi OS and just block the Microsoft server, which is good enough. So over here on the download page, head on and find this here link. The installation images can be found over here. There's the archives. Here's the OM files for single boards. The 5.5.11, this is what the current one is. So you can go ahead and grab the ISO and then grab the verification keys to make sure you have everything. These ones are older versions. So if you do need something much older, you can go way back to the older versions. In the event you need to do that. They do have the install scripts are over here. Now this is going to take you to a big user guide, and we're actually going to have more details about what's in that user guide a little bit later. Most of this is the guide for the person who knows absolutely nothing about putting something together. It literally is like 18 pages of walking you through how to download and write an image on Windows. And so we don't have that issue here necessarily. You can follow that guide, and it's very user-friendly to a person that is new. But if you follow this here, pretty much we just need a couple commands at the bottom, but we're going to be talking about the installation a little bit later. As far as how to manage the software once it is installed, it is actually quite easy to manage, and we'll actually have some tips and some tricks about that. But I just want to go ahead and walk you through my basic interface panel right now. We'll look at how the system resources are handling and things like that. So this is actually the login here from my office. So this is my microcomputer, so the tower. This is not the one we're building. This is my current running system that we are hoping to replace. you can come on in here and we can see everything about the disks that we have. We can do the RAID management. We have DLNA service, which is an extra add-on. I also have the USB add-on. What these guys, the USB backup add-on, this actually allows me to sync my data to an external USB drive. The DLNA, of course, this is a just the plug-and-play media server. It works fairly well for just pulling up my phone, picking the shared servers on VLC, for example, and playing some piece of music that is in my system. If we head on over, here's our dashboard. That's where we started. Here's our system information. So you can see here that this CPU is actually running at 9% CPU usage and 5% of my 4 gigs of RAM. So how's this going to compare to the Pi? Actually, in my side-by-side comparisons, they're very equivalent. There's times actually the Pi runs more efficiently than this. So you see that we actually have all the different features that we need. And here's our users. So you can see I have a master user. The Calibri is for my book server. We're not setting that up in this video. I'll do that on a separate video later. Here's the various shared folders that I have inside my NAS. Now, that's this allows me to share everything exactly the way I need it. Most of the things on here require a password. There are a few things that are anonymous access for very quick file transfer across computers and devices connected to the network, but most of the things I actually have locked down into administrative accounts. I also actually have a nice thing set up on my router where I can actually type in a local DNS name, which is omv.com, which redirects you to this instead of having to use my IP address, which is a nice and handy tool. So overall, I'm very happy with OpenMediaVault. I realize that there are other alternatives out there in the world, but honestly, I love it so much, I'm just going to go ahead and build my new version. So the next thing we're actually going to look at in the course of the video here is we're going to go over and have a look at my current setup, what that looks like. We're going to look at that power usage and just kind of some basic considerations. So we'll go ahead and have a look at that system, how it sits right now in my office. So here we are at our current setup. And you can see it's a little bit of a wiry mess. Now, that yellow guy on the top there, that's not usually there. That's actually plugged in just so we can get our power readings. Usually that big computer, which you see there on your left, is going to be plugged into the power strip, which you see on the back of the right. You can also see there's a lot of things down there. Some of you guys might be like, oh, cable management. Well, you can't always manage cables quite that well. But one of the things we're going to do in this project is we're going to do better cable management. But nevertheless, this actually works pretty well. What all is down here? Of course, we have over here, we have my modem and my router. So the modem is just a basic Aris Dock 3.0 modem that works with Comcast. And then the router there is a Fitlit PC that is running pfSense. This guy here is the tower that is running the current NAS. And the biggest challenge that we have right now is the power consumption. And that's really what we're going to be looking at. So you can see here on my power consumption, this is currently reading at volt amps. So I got to get my, let me switch to manual focus there. All right, so that's going to be good enough. I'll just have to read off what we're looking at here. So we're bouncing around about 18 to 20 VA. So your VA is a volt amps. This is how much power is actually coming out of the wall. So if you're using one of these kilowatt meters, this is the watts. The problem is that the watts is not actually what's drawing off the power grid, and I'm actually more concerned with what's drawing off the power grid. So the computer's running at about 7 watts. But it's drawing a VA of 18.5. That's because the efficiency is not particularly good. The PF, which is a measure of the efficiency, is at 37%, which means there's a lot of waste going on in this computer. And that's one of the things we want to cut back. So here's our amperage. So of course our voltage is at about 120. Our amperage is about 0.16. Our VA is 19-ish. And then, of course, our hertz. So that's kind of what we have, and this is what we're going to be fighting with, is we want to get this number, technically we want to get this number, the VA, down as low as we can possibly get it. And that's what I'm hoping to build the Raspberry Pi NAS to have the same exact job this computer is doing, but for a fraction of the cost and for a fraction of the power. So let's go ahead and talk about how we're going to build this. All right, so now that we saw how it is, let's talk about how we're going to go ahead and get this guy all set up. So as of right now, we're going to need a couple of individual components. Obviously, we're going to need a Raspberry Pi. According to the guys over there at OpenMediaVault, you will probably want to use at least a Pi 3 if you have one laying around. Pi 2, they say will work, but it's not going to work well. This guy here is the 4GB Pi 4. I have it inside this case here. Now, initially, as I was running this, the fan on these were very loud to keep going. That was one of my biggest concerns, is having a loud fan. And I'm like, man, that's really loud compared to what I have, which I can barely even hear the one that's running. So I'm like, that's kind of bad. But there's actually a little bit of documentation stuff where the Raspberry Pis have a variety of different power output pins. So if I can go ahead and focus on this guy here, whoa, there we are. So right now, the way the instructions on this particular Raspberry Pi tell you to do it, it tells you to put your red pin up here, which is going to be on the 3rd pin on the top row, and then your black one right next to it on the 4th pin. The 4th pin is ground. There's actually several grounds on the board. You can use any of the grounds, but that's actually the most convenient. The problem is that this one here, the 1st and the 2nd pin on the Raspberry Pi board are 5.5 volt outputs. And that actually pushes a ton of power through this little fan, and we get a little fan pushing that much power. That thing will keep this processor absolutely freezing cold, but it's going to be loud when it does it. If you actually just pull this cable out and plug it into the 1st pin on the bottom row, that's actually a 3.3 volt output. So I'm actually changing this, and once I made that change, this guy here still keeps the Raspberry Pi cold enough, but I can't hear the fan anymore. So I can go ahead and keep this case. Nevertheless, I have actually ordered a better case, which we will actually put this Pi in by the time we get to the end of the video. But as I said, I'm recording this quite a while before I actually finish the product. So what I actually bought for this is a complete passive cooling pure aluminum case, which basically turns the whole Raspberry Pi into a giant heatsink. No external power at all, which is good because the Pi is also powering my hard drive, and I want to save as much power as possible for that so the Pi does not get itself under a lot of stress. Now, you can use a standard external hard drive, which they're getting very cheap. You can get a 2 terabyte one for like 50, 60 bucks if you find a sale. Even outside sale, they're really only about 80. What I'm actually using, though, is I have a 2 terabyte Barracuda hard drive here. And this hard drive here is, this guy's a nice laptop hard drive. It's fairly low power, so this guy here will be very sufficient to run off of the USB. I did want to go with something that's explicitly lower power. This one's a 5 volt 1 amp hard drive. Some of the laptop ones can get a little bit more. And then at the minimum you're going to need a SATA to USB 3 cable. Make sure you're doing this USB 3. You're not going to want to contend with USB 2 speeds. Of course, the Raspberry Pi 4 board does have 2 USB 3 drives on it, so that's what we want. So basically, at our simplest configuration for what we're going to be doing is you're just going to plug your hard drive into there, plug your other hard drive into here, and then you just need to supply some power and a network cable, and we should be ready to go. Now, before we actually plug in the hard drives, we can go ahead and get OpenMediaVault all set up, get the distribution all set up, and all the other tips and tricks and tools that we need. You can go ahead and get all that kind of stuff set up before you plug in your hard drive. We don't need to be doing that until the end. And I actually have extra steps. We're going to be walking through all of the steps of setting up the distribution, all of the tips we need to do, get OpenMediaVault set up, and I'm going to show you how I've configured this in the following steps. So during the time I was filming this, the process of getting Raspberry Pi OS has changed. They're just kind of doing a little bit of different things that they think will make it a little bit easier for some people. So let's go ahead and walk through a couple of the changes here so you can decide what is going to be best for you. You head on over to Raspberry Pi and look for the software or software. You can find the operating system images. This is their new way of doing things where everything is a little bit separate. With the Raspberry Pi with desktop and recommended software, this is basically gets you like effectively like a full operating system. You have Raspberry Pi OS with a desktop. You have Raspberry Pi OS Lite. This is actually the one that you want. You don't need anything with any desktop environments or things like that. So this is actually the one that you want. You also have other options to get like LibreELEC, Ubuntu Desktop, Ubuntu Server, Ubuntu Core, RetroPie. There's a few other things on there as well. So that is the current way to grab it. Now, you might still find instructions for noobs. In fact, I had initially recorded this video utilizing noobs, so let's walk through that as well. If you find the documentation and installation of noobs, I like this one best because you have one installation media, and then this allows you to install all those and a few other options as well. And so I like this one, but I think they considered it a little bit too advanced, and Raspberry Pi is targeted towards a more basic user. And so this still exists. They are still updating it at the time I'm recording this video, but you need to go into the raspberrypi.org/downloads to get it. And that's probably this page. Let me go ahead and pull that up just to make sure. No, see, that link takes you over to here, which doesn't have noobs. You need to get to downloads.raspberrypi.org, and this is actually where you will find your noobs. I think I recorded most of the video clips here somewhere in February. It's now kind of the ending of March. Tells you kind of how my month has been going, but they actually just now have a brand new version released not too long ago. But this is where you want to go ahead and grab your noobs, and then you can grab your archive or your images of it. And this is actually what I'm using to show you how to install this. But you can actually go back to your main operating system. You can grab the ISO that you have, and then these guys are going to be ISO images that you can burn onto the SD card, or if they're zip files, you extract them and do the next method, and that's kind of what I'm going to be showing you now. So what we're going to do here is we're going to format our SD card into FAT32. I'm using the built-in Linux Mint USB image writer, and I'm just plugged my SD card into a USB stick adapter. Now, what's important here is that this is FAT32 and that these extracted files never touch your ext4 format. Something breaks it if you do that. So without extracting the archive, I'm just opening up the archive here, and I'm just going to copy everything over onto the freshly formatted SD card, which has been freshly formatted into FAT32. Now it's time to boot the Raspberry Pi. I'm just going to drop the SD card directly into the back of the Raspberry Pi, supply power, and you're either going to need to plug in a keyboard and a mouse for sure, and you will either need to plug in some monitor into it, or in my case here, I'm actually just monitoring this off of my capture card. So I'm just basically squinting and looking at the small version of OBS. You can go either way. Now again, this is Noobs. So what Noobs is going to do is it's going to go online and grab the current list of software that you can install. We have here the ones we talked about, the full Raspberry Pi desktop with recommended applications, and you can see they're recommending that. Well, that's because they're just assuming you want a desktop environment. We don't need that. What we want to do is we just want to go ahead from here. We want the Raspberry Pi OS Lite without the desktop. So it's going to be the third one down on this list. Notice the other one, Raspberry Pi OS, a port of the Debian with Raspberry Pi desktop. We do not want that one. If you're curious, the LibreELEC, this actually gets you a very good Kodi build. There's a data partition, there's RISC OS, there's looks like there's a RetroPie emulator, and you can go ahead and do that. Now this, I've went down and I've selected my language and my keyboard. Raspberry Pi by default likes to use a UK keyboard layout. So go ahead and fix that. Now we're just going to go ahead and wait for this guy to install. At the end screen, it's going to prompt you to reboot. So we're going to go ahead and reboot our system. And then this is going to reboot into our Raspberry Pi server, which is going to be a command prompt. Now, we don't want to be managing everything directly on the Pi with a keyboard attached or the monitor attached. So what we're going to do in this step here is we're going to go through the Raspberry Pi configuration, enable the SSH server, and maybe a few other little things before we go ahead and reboot the system, and then manage it through our SSH. The default login is Pi for the username, and the password is Raspberry. Make sure you change that because you don't actually want to go ahead and have your Pi available with that in case somebody breaches a network or something. So what we're going to do here is we're going to access the Raspberry config. So it's rasb-config, and make sure you do that as a sudo. And then now what we're going to do is we're going to go through our various different settings. So first we're going to change the password. This makes sure that we're no longer just using that default password of Raspberry. So I'm just going to go ahead and change the password to what I want my production password to be. Any of these steps that prompt for a reboot, we're not going to do it yet. We're just going to go through all of the options that we want to do first. Here's our interface option. F2 gets us our SSH. We want to go ahead and enable the SSH. That's going to enable us to access the system through our platform. You can go through and disable that if you need to for extra security, but since this is not on the host network, I generally don't want to mess with that. Here I'm going to change the host config to PyOMV. That's just my internal, what I'm going to call this in production. And now we're going to go ahead and select the boot option. We can do console, auto login. We can do desktop. So we're just going to go ahead and log into the console, which is going to not log the whole system in. We're going to want to get in there and SSH in and log in if we want to do anything else. We can disable that power LED there if we want to. See a lot of the different options here that you might want to change. So once we finish everything, then we're going to go ahead and reboot. So now that we are rebooting, we're just going to go ahead and SSH in here. So now we don't have to worry about the capture card or external monitor. We're going to do the updates. So sudo apt update. We can see 37 upgradable packages and go ahead and push the upgrade. In the meantime, we're going to have another look at this document. I said a lot of this, literally over half of this document here is just how to write the image file onto a disk. We already did that in one early step earlier, so we're just going to skip way down to the bottom down here. We did the update, you did the upgrade, and now we're going to do this network 99-default.link. We're going to remove that file once this is done updating. This took, I don't know, about 5 or so minutes to update. I will cut some stuff out here. So we're going to remove that file. What that's going to do is it's going to prevent networking issues coming on with the Raspberry Pi. It is a known issue. Next, follow along the documentation, paste in the code there to get and install the OpenMediaVault, and that's going to take about, I'd say that took about 10 minutes here. I cut a lot of time out of here. And then once we do that, we're going to go ahead and reboot the system, give it some time to get online, get the web server up online and things like that. And then you just need to go to whatever the page is. You can see here it's 192.168.5.151. So I'm going to go ahead, pull up a web browser and just type in the IP address into our system. And I'm actually creating a internal local domain name for it as well. But once we enter that, we go ahead and get logged in. The default username is admin. The default password is OpenMediaVault, all lowercase and all one word. Be sure to change that when you are done. All right, now that we have the Raspberry Pi OS installed and we have installed OpenMediaVault and we've landed on the home page where we're going to be setting everything up, we just need to do a couple things here. Just get your Pi. Like I said, the case still isn't here yet. I'll go ahead and get this guy in the case a little bit later. And who knows, maybe I'll get an external hard drive enclosure for this because you definitely want to protect this hard drive. So I am going to be getting an external hard drive case for that, which we will have in the final build of this guy. But let's go ahead and just attach your SATA drive over here, your SATA drive adapter to the USB. You're going to plug this guy in, and then for basic configuration setup, I'm just going to go ahead and leave it right here on the desk. I've already set up, in the videos you saw me set up the SSH, so I don't have to worry about plugging anything else into the Raspberry Pi. I'm just going to go ahead and do everything manage-wise here. So I'm just going to plug in an Ethernet cable. You don't want to be running this on wireless. Wireless is going to dip in and out at times. It's not going to be as good and as predictable as if you're hooking into wires. So make sure you're plugging this guy into the wires. Take advantage of that full gigabit Ethernet port on the Raspberry Pi 4. So plug into that guy, wire this guy in, and then we're going to feed some power into it. And then you can just go ahead and set it somewhere. I'm just going to set it right up here on my desk for now. And then when the thing is done and I have all my data transferred onto it, then I'll just go ahead and place it in its new home. So now we'll walk through the configuration. Now I did already come in here and get this guy configured. And the reason I didn't want to do it live is there were a couple things I was doing different on this system, such as encrypting my drive. So we'll go ahead and walk through the basic setup that you would need to get this guy running up on your server, and then you can go ahead in here and play around. So when we first land on the dashboard, we see our services, mini DLNA. This is a plugin I have enabled so that I don't have to configure stuff. I just get in here and it will find my drives. I did notice that probably starting maybe about 6 months ago, sometimes this thing gets a configuration file out of whack, and I might have to log in and clear out a configuration file. And that does seem to be happening on this one here, but I do stay logged in on the most important media servers I need, so I don't generally let that bother me. Just something I've noticed. I've enabled NFS over here, or maybe, no, I think NFS was already enabled. And I keep SMB CIFS enabled. This enables me to get in here and share files easily. We have the information that we have. We can see that we're on the Raspberry Pi with the ARM v7 processor, Rev 3, Linux 5.10. Now, the first thing you might want to do is get into your general settings, go over to your web administrator password, and enter yourself a new password. The default, which is admin and OpenMediaVault, you're going to want to change that, even though this is not designed to be accessible on the internet, but still for extra security, you're going to want to do that. Once I do that, I log out and log back in. I don't care if this stays on port 80 or not, because this is an internal system. So I'm not worried about man-in-the-middle attacks or anything like that. So I just keep this at 80. This prevents browsers from, we blocked the connection because there's no valid SSL. It's my own network. So I just go ahead and keep that at 80, and then you can change your logout time if you want. You can enable the certificates, you can create one, or you can just have a self-signed certificate, but many browsers will yell at you for that. Like I said, I don't generally bother with that, but depending on your setup, you might need to. If you're using this in a larger system than me and my network with one person working in the office, you might very well want to do that. As far as everything else in here, we're not going to go through much here, but you can go into the update manager and you can check for updates here. Now, I went ahead and ran updates when I first set this up. You can see that there are a number of updates yet to do again. I usually do updates maybe about every 6 months or so. Since it's an offline server, I do updates about every 6 months or so when I have specific time. So eventually within the next month, couple months here, I'm going to go ahead and update those. We do have several plugins that some of these I find very useful. So there's the USB backup. This plugin I always enable because it allows me to plug a USB drive into the USB port, and it will automatically sync my drive over to the new drive. We set up, let's see, I think that was already configured. I set up Lux Encryption. This is the first time. So now my entire media drive is completely encrypted. Now this carries with it a downside that every time the system reboots, or if you turn it on for the first time, you are going to need to go in and you're going to need to decrypt the drive in order to access the files. So keep note of that. But I thought that that would be a good option. Here's, of course, the mini DLNA. That is another one that I generally activate, although right now, in my experience, it's not working quite as much. Now, the extras repository, many of those that I already covered are only in the extras. So you might have to enable the extras, check updates, and then you can go ahead and install those other ones. So here's the extras. You can do a testing or not. You can do the extra or not. You can do the backports or not. The next area is your disks. This is going to show you everything. So this one here is our SD card, and then SDA1 is the main data disk that I have. Now this build, on my old one, I had 2 hard drives that are always synced in a RAID. This one here, I only have 1, so it is more important that I do those regular backups more consistently. Over here, there's your smart encryption. This is added with the plugin. What you're going to need to do if I reboot this, or if I lose power and it reboots, I need to come in here, click on the drive, and hit the unlock and enter my password, and that will enable all of my server folders to be found. So that's what I'm doing. I'm not using RAID management in this case. I'm not even sure you can use the RAID management on the Raspberry Pi. I just don't know the answer to that. I've seen conflicting information about it, and I have not tried. Here's your file systems. It is going to give you all the file systems and where they are at. 4 of these are on the SD card, and then the last one is actually our data drive, which you can see I have a 2 terabyte data drive in here. Now, what you need to configure in order to use this is you need to get some users and groups and such configured. So I have my admin and I have my Pi user. I think that these ones here are already configured and you're good. If you need to have a separate logins or anything like that, you can go ahead and add those users. I just keep with these because this is something internal to my network. And then shared folders. This is important. Once you have your data drive up, the next thing what you need to do is create shared folders. So these are actually going to appear on your shared system. So I'm going to go ahead and show you here my network, double click on this, and what we're going to see is the shared folders. So we have the admin, which is kind of our backup. Then we have, I have a backup, which you don't see here because you can see it's not referenced. Anything that's not referenced will generally not show up here. These will only show up if I actually log in under my admin. So let me go ahead and log in, and then you'll see that there's more stuff in here. Now the admin password here is one that we are using for our folders. This is not the password to get into the web interface that we are working with. You can see that now that we're logged in under admin, you can see that this opens up a lot more folders that I could not otherwise see. So we have, I have Christian video, documents, music, NetShare, OpenShare. So I use OpenShare. This guy here does not require any password. I just go ahead, click on it, and I can interface with anything on the network. The NetShare, I have to be logged in. I use it for more sensitive sharing between computers. Here's pictures, sermons, and video. So these are all the different folders that I am using. So you have to set each of those folders up. So let's go ahead and look at one of the edits. So you basically just select what disk it's used on. You give it a path, and then it is going to be here. Now, where the reference comes in is how you actually access that drive. So how these guys end up getting shared is you attach them under your services. So what's most important for me is the SMB. So this, you need to set it as enabled. You need to set it as browsable if you want things to be browsable or not. And then under your shares button, this is actually where you're adding these different folders. You can see my OpenShare is set to guest. So this allows me to, without a login, enable to go in, read, and write into the OpenShare from any device on my network. Everything else, you can see public is no, read-only is no, browsable is yes, but in order to get into any of these, I actually have to log in. So let's just go ahead and double-click one of these. Here's the shared folder. Here's where I set the public. Here's where I set all of the different options that I want to have. So in order to set up who can actually access these folders, this is where we need to go back up, down into the shared folders. Then you need to find your individual folder, and then you need to set your privileges. Now what we see here is that all of these I have set at none, except OpenShare might be different. I can't remember if I have that one set up. Yeah, I don't do anything because setting that to be in the folder to be accessible everywhere, you don't need to do anything. But if I go in here, basically I have all these guys set up so that I have to log in as an administrator. So under the admin folder, which everything else is under the admin folder, you can see that the admin has read-write privileges, but nobody else does. And so this locks all of my folders into requiring admin privileges, except for OpenShare, which I've configured down in the shared folders as being open to, actually I think it's down here in the services as being open to public access. So there is how we have gotten this guy all configured. And then you can turn on a variety of different options here. So you can see where the DLAN is, and I'll go ahead and clear this guy out. And so hopefully that will get itself fixed. You can enable or disable FTP, NFS. I really only worry about SMB and SSH so that I can actually get in here and do a little bit of system management. There are some different diagnostics in here and some other information down there, but hopefully this will be enough to get you started on configuring everything for OpenMediaVault. So here we are after we have attached the Pi to the wall. I'm not going to show you what the wall looks like yet. We'll get there in just a moment. But over here, this is what we're reporting. So we are at effective watt usage is 4.6. The VA, this is the important one. This was, I think, around 26. This is now down to 12.9. And the amps is now 0.10 to 0.11. So you can see that overall, the Pi actually greatly reduced the power consumption, pretty much cut all power consumption across the board in half. And that's actually a really good thing. So let's go ahead and have a look at what the wall looks like. And now here is what our final area looks like. Rather than having the old shelf with everything down there, we've now mounted everything nice on this corkboard wall. And not perfect cable management, but I would actually say pretty good. So some of the earlier supporters that already saw this photo said it was maybe about 7 out of 10. I actually made a few modifications since then. And now what we have coming in, now this part down here, these guys are all attached together. This is the gray wire here is the main Ethernet going back into the office network switch. This is, of course, the cable for the modem there. And then this is the Cat6, which goes downstairs to the extended network and the Raspberry Pi in the back of the TV. So we go up, of course, we have our modem here going up into our pfSense router. And then this guy is where it goes downstairs. This guy in the middle is out to the office. And then this one we nice and rooted it right around here. This guy is onto the Raspberry Pi. This is the new passive heatsink case. So this case here turns the Raspberry Pi into one giant heatsink. And bonus, we don't need to run any extra power for the fan. And so taking the fan off of there didn't save a lot of power, but saved a little bit. We probably could cut power back more if we swapped our standard hard drive here with an SSD. And I don't know, I might do that down the road, but for now we're just going to go ahead and run with that. So now everything is in here, nice and easy. The modem is plugged in right up here. The router routes around on this side, and the Pi routes around on this side. So there we have it. Now I have one giant geek wall. This is the stuff that's always on in my office, of course.
So now I have an always-on Raspberry Pi nanoscale NAS that consumes almost no power at all. This allows audio and video streaming, file sharing across the whole network. It will run an ebook server here when I am done with that part. And there is what we have it. So there is the end of that part of the project. And I hope that you guys have enjoyed that.
Thank you for watching this video from Switched to Linux. This channel would not be possible without the backing of the program supporters scrolling on the screen now. You can be a supporter at Patreon at patreon.com/TOMM or at thinklifemedia.com. I also want to thank the open source community who creates such excellent software that makes producing this show possible. Please remember to support your software communities. Thank you, and I hope that you enjoy switching to Linux.